Welcome to the Everything Building Envelope podcast. On this show, we discuss topics relating to the exterior building envelope, such as waterproofing, glazing, cladding, roofing, and more. You can subscribe to this podcast on iTunes and Stitcher. For previous episodes, show notes, and bonus video content, check out our website, everythingbuildingenvelope.com. Now, here's your host for the Everything Building Envelope podcast, Paul Beers.
Welcome, everyone, to Everything Building Envelope. Paul Beers here, and really excited today to have this is our guest, Chris Matthews, who I work with at GCI. And we've got a really interesting topic today, which is waterproofing exterior walls. May not sound so interesting, but it's pretty complex, and there's a lot of different items that that I think our listeners will be very interested in that we're going to discuss. Chris, we've worked together for quite a while now.
Quite a while, yeah.
Yeah, so I remember when you came to work for us, you were had relocated up to Atlanta.
Right.
We were trying to establish the Atlanta market, which we have done. You know, obviously we have an office in Atlanta now, and you still go up there quite a bit.
Quite a bit, yes.
Yeah. So it's been a long and fun relationship working together. So Chris, why don't you just give us a little bit about your background and basically what you're doing for GCI these days?
Well, I came into the construction industry right out of college and went to work for a large glazing contractor. So that's my background, is in the glazing end of things, and then evolved into other areas of the building envelope. Joined GCI in 2002. And I've been working in the exterior envelope consulting arena since then. Been in the business now for 30 years. I remember when I started, I'd go to meetings, and the old guys would say, "Oh, we've been doing it this way for 30 years." 30 years was the magic number, and now, unfortunately, that's where I'm at. Hopefully, I'm a little more open-minded than some of those old timers were.
Yeah, please tell me you're not doing what you were doing 30 years ago.
No.
So let's talk about waterproofing exterior walls. When I think about that, there's two primary kinds of construction that we typically see. What I would call masonry, which is a concrete frame with concrete CBS or concrete block infill. And then, of course, what's probably a lot more of out there is the framing and sheathing type of systems, and it could be metal studs or wood framing or whatever. So is there differences in how you would waterproof those types of applications?
Yes, we see a lot of both types of construction, and there are definitely very different approaches as to how to construct those walls, design those walls properly to handle water to prevent water infiltration.
So let's talk first about the masonry construction. I know, and I hate to admit this, back in the 80s and 90s when I was a window installer, they would erect the system, and we would put the windows in, and they would stucco and paint and caulk, and we'd move on. And there's a lot of mass there. There's a lot of stucco and concrete for water to get through before it gets to the inside of the building. And that generally, I think, was effective. But is that enough, or do you think that maybe, or what's being done nowadays as compared to 30 years ago?
Well, sure, and I remember the same type of construction you described, and there are still people who ascribe to that method and want to do it that way. I think what we've learned over the years is that when you've got extreme climates, extreme weather situations, you do get water in around window and door openings if all you do is paint the stucco and apply a bead of sealant between the window and frame, the window and stucco. So what we do now is what we recommend is to try to address that opening before stucco is installed, before windows are installed, and install a fluid applied waterproofing around the perimeter of the rough opening to provide a waterproof substrate at that opening.
So how when you say around the opening, is that just inside the infill where the window goes, or does that go out on the wall? How far? What's the particulars with that?
Yeah, we go around the perimeter of the opening, and typically we like to see it turned out 4 to 6 inches out onto the wall around the opening.
And why is that important?
Well, you can have cracking. You can have any opening is a hole in the wall, so you can have a lot of imperfections and materials coming together there. So we like to turn that out and waterproof that whole area so there's no paths for water to migrate in around the opening.
So then what?
So once that waterproofing's installed around the opening, the next step is for the window installer to come and start installing the windows and the doors. Those are installed with a proper space around the window between the frame and the CMU wall, and then
So I'm sorry to interrupt, but what is what's a proper space?
we like to see a minimum of 3/8 inch. A lot of jobs are designed even with more up to a 1/2 inch because construction materials vary. So if you design all the sealant manufacturers, materials are designed for a minimum joint width of a 1/4 inch. But if you design a building to a 1/4 inch, it looks fine on paper, but we all know out in the field materials vary, and you can start to get joints that are too thin and don't perform properly over time. So we'd like to see a 3/8 to 1/2 inch joint designed.
And so that sealant joint, what kind of sealant do you typically use there? Do you have to use primers, bond breakers, all that kind of stuff?
Well, we like to see a high quality silicone sealant. It's the most durable, it's the longest lasting, and the best performing for the building over the long haul. And yes, we recommend pre-construction adhesion and compatibility testing of the sealant to all of the contact materials, but in this case it would be the waterproofing material and the aluminum window frames, and then field adhesion testing as the process as the sealant is being installed to verify that we're getting the adhesion and performance that we need.
So who would do this field adhesion testing?
Well, we can perform the field adhesion we can perform the field adhesion testing, or the local representatives of the various sealant manufacturers can come and perform the testing, and we'll be there and witness it.
Now, if a sealant manufacturer performs the testing, what do they charge for it? And then do they, just call it good and walk away, or do they provide any documentation, or how does that all work?
It's a free service, so definitely something that should be done on every job. And the manufacturers provide an actual test report with a pass-fail rating on each of the substrates that the material was adhered to. And if there is a problem, they will get involved and provide further testing and recommendations for what needs to be done to get proper adhesion. So it's a valuable process that costs nothing, and definitely we recommend it to be done on every job.
Sounds too good to be true.
Exactly right.
Okay, so so basically our window's roughed in, it's sealed to the structure. Then I guess the stucco.
Yes, then the stucco's installed, and the typical detail is for the installer to rake a groove to return the stucco back toward the window, not in contact with the window. Rake a groove at the perimeter, and then the stucco's painted, finished in whatever manner it's going to be finished, and then a second sealant joint, some people call it a beauty bead, is installed between the window and the finished stucco to complete the installation.
And you mentioned that the stucco should not be touching the window frame. Why is that important?
Well, the stucco is a cement-based product, and cement and aluminum don't get along well. If cement and the aluminum frames are in contact over long periods of time, and water is added, which obviously it would be at the exterior of a building, the cement-based stucco can corrode and break down the aluminum. So they have to be separated, not just stucco and aluminum. Anywhere that aluminum frames would be in contact with any cement-based material, there has to be separation or isolation.
Have you seen instances where maybe it wasn't done, the way that's recommended, where the stucco has contacted the frame?
Yes.
And,
yeah.
And what happens?
Yeah. It's a major problem for the project. It takes some time. You're not going to see major results in 3, 4, 6 months, but after a few years of contact, there can be major corrosion and breakdown of the aluminum to the point that you may have to replace everything.
Sounds expensive.
Yes, definitely.
Yeah. For something that's really simple, right?
Simple, yeah. It's just a matter of an installation method and some materials, films, fillers, something to separate the stucco from the frame when it's originally installed.
So, the other type of construction that we're talking about is the frame construction, I'll call it. And when I say frame, people I think always think wood, but that could be metal studs. Conceptually, it would be the same difference from a design standpoint, wouldn't it?
Sure, yeah. And you see a lot of the heavy gauge steel studs in bigger buildings, taller buildings, commercial buildings versus the residential application. But we see both wood frame and steel stud framed all the time.
And then these framing systems would have a sheathing applied over it, which could be some wood-based product or a gypsum sheathing, typically, correct?
Yeah, we see. I get the three types we typically would see would be plywood sheathing, oriented strand board or OSB sheathing, and then in your steel frame construction, it's typically a fiberglass faced gypsum sheathing.
Yeah, and when you say fiberglass faced gypsum sheathing, is there a paper faced exterior sheathing available?
Well, yes, and there was a time when that was the standard in the industry, but it has virtually no resistance to water. So the fiberglass faced products are much better at handling incidental water and preventing breakdown of the sheathing.
And most people are using them these days?
Yes.
Even though they're maybe a little more expensive?
It's more expensive, but it's widely accepted in the industry that that's required. So in the construction documents and actual buyout of materials, we see the fiberglass faced used almost everywhere.
And then, so with the exterior wall systems, they could be clad with I'm sure different things like stucco, brick, wood siding, metal panels, stone, lots of different things, right?
Yes.
So what keeps the water out in these kind of systems?
Well, in this type of system, you have to design the construction and the wall details with the assumption that water is going to get behind the different types of cladding systems that you described. Brick, stucco, siding, panels. Every one of these water can and in most cases will get behind that exterior cladding. So the wall has to be designed to handle that moisture. And there's a weather resistant barrier, a WRB, installed over that sheathing, both sheet type materials, wraps, that people are familiar with, and then another option are fluid type weather barriers, fluid applied weather barriers.
And before we talk about them, just very briefly, I just want to touch on the fact that we were talking basically about a drainage based system. There's also, and they're not very popular anymore, I think, because of a lot of failures. There used to see a lot of barrier systems. And can you just tell us the difference between what we've talked about now, the drainage system, and what a barrier system is?
Yeah, a barrier system, in theory, on paper, it's not that bad. If you've got a material that has a waterproof exterior plane, and you install that on the building, and in a manner that you think no water will ever get behind it, it's like a glove on the outside of the building, and everything's good. The problem is joints break down, there's cracks, there's penetrations, there's other paths that people didn't anticipate water getting behind these barrier type systems. And once they did, the material did just as good a job of holding water in as it did holding water out. So now you've got water behind that material, held in up against materials back in the time when these were most popular, like these paper-based gypsum products we talked about, and you can have just catastrophic damage to the building. So the barrier system, in theory, can be good, and there's still times, like you said, when it can be applied and done effectively. But by and large, we see the jobs as designed with a drainage type system that anticipates some water behind that exterior wall cladding, and with flashings and weather barriers installed in a manner to control it and get it back out of that system where it can't damage those walls.
So tell us about some of the different types of weather barrier systems that are predominantly being used these days.
Well, kind of the old school is just the asphaltic building felt. You still see it in Home Depot on rolls, and they put it on shingle roofs. But it's just an asphalt impregnated building paper, and it can work as a weather barrier. It's got some weaknesses in that it doesn't hold up well out in the sun and weather prior to the exterior wall cladding being installed. It's easily torn. So there's some potential problems with that. You've got the wrap type of weather barriers, which is the most popular, I think, especially in your single-family residential, that type of thing. There's some big names in the wrap type of barriers that people are all real familiar with.
Like Tyvek.
Tyvek is probably the most familiar. It's like a Kleenex. Some people call a tissue a Kleenex. A lot of people call any type of wrap Tyvek. So most people are familiar with that. And then what we see gaining more popularity, and that we're big advocates of, are fluid applied weather barriers that are actually rolled or sprayed on to the exterior sheathing to provide that protection before the wall cladding goes on.
And why do we like that better than the sheet materials?
Well, there's a lot of benefits to that. One difficulty with the sheet materials is sequencing, in that everything on the control of the water and the drainage of the water out from behind the cladding is so important to the longevity of the building. And to do that, everything has to be shingle lapped, with each successive higher area lapped over the lower area, so that water flows down to a flashing location and out, just like a shingle roof. Each level moving up the roof is lapped over the layer below. That can present a lot of difficulties because of sequencing during the construction process, in that certain things may be installed before or after the wrap, and creating conditions where those materials aren't easily lapped in that manner, and where there are paths for water to get behind that wrap type of barrier. So we've seen a lot of buildings with failures where that's the problem. Not that the wrap is not performing, but that there were paths that for water to get behind the wrap and then cause damage, like we talked about earlier. So that the fluid applied eliminates that issue. You can roll or spray on your main layer of the material, and then if you've got to add something else, I forgot, or sequencing or whatever, and you've got to put a condition with a negative lap, you can just add more of the material and resolve that. The other thing that we like about the fluid applied is even if somehow water gets through it, behind it, at a specific location, everywhere else it's still adhered to the sheathing. So you don't have water running down behind material and causing damage as gravity just pulls it down behind, like we've seen so many times behind the raft types.
And I've also seen and heard that another advantage of it is that you can color it so that you can actually, when you're doing an inspection, you can confirm that you've got good coverage, because let's say it's yellow and you just make sure that there's yellow everywhere. Exactly,
yes, and they design it just like you said, and the different manufacturers have their different colors, but they design it so it's pretty much foolproof in that if you see something reading through, then you don't have it on thick enough. But if you've got a constant, continuous color, whatever it may be, you've got the material installed adequately.
So as we're doing this podcast, and the construction industry is very busy now. You go through any city in the U.S. and you see cranes and construction crews and whatnot. And, so you'd mentioned foolproof, and how does that help in times when it's really busy out there?
Well, you definitely want to make it as simple as it can be to get it right, because there are so many materials coming together at the exterior wall, and each of those materials taken on its own is probably very good, but there are so many joints and connections and intersections between all of these materials, and in busy times people are spread thin, there's not as much supervision, there's maybe not as much experience in the actual installers. So you want to make things as close to foolproof as they can be to prevent all of those joints and transitions from becoming a problem.
So in an exterior wall system, I know one of the big problems areas can be openings in the wall system, windows, dryer vents, hose bibs, light fixtures. What kind of special attention needs to be paid in those areas? And I guess let's talk about window openings first.
Yeah.
What do you have to do at a window opening?
It has to be flashed properly with whatever type of weather barrier you're going to use. That the typical flashing materials for window openings in the frame type construction is an adhered membrane. People call it a peel and stick, flexible type flashing, and this has to be installed properly around the window opening or any of the penetrations that you talked about, dryer vents, door openings, whatever the hole in the wall may be. It needs to be flashed with the peel and stick type material that ties into the weather barrier and creates a continuous protection, a continuous plane that won't allow water behind the barrier like we talked about earlier, or in at the holes in the walls that all of these penetrations create.
And you say it has to be done properly. So who provides the information on how to do it properly? Do you see it in construction details, or do the installers just know how to do this? I mean, how does this happen so that it gets done properly?
Well, I see more and more now where architects are trying to address the proper flashing of openings and penetrations in their drawings, and we certainly assist when we're doing design assistance work with trying to get those details right. But there are a lot of very fine details in getting that right, and so it's a difficult thing to draw and show properly. So what we like to do is get out there and work with the people who are going to be installing this and get the first of each of these type of openings and work it through and have everyone agree that this is the proper way to install it and this is the way we're going to do every one on this job.
So let's just talk about that a little bit, the sequence of events. Obviously, let's say that we've got a set of plans that may or may not show how to do this or how to do it properly. What happens from that point forward? There's contractors, subcontractors, we're ready to go. What do we need to do to make sure we have a successful installation?
Well, we like to get those plans right. Most jobs they are right. Some they may not be. But regardless, you got to get that's got to be communicated to the field, to the people out actually installing this stuff. So what we like to do is get to those groups of actual installers together and get them out on the job. And we'd like to see a mock-up of some type constructed to where we've got the various conditions and materials that we're going to be installing on this job, and we just work it through. Because let's face it, no matter how good those drawings are, a lot of these guys may never even see the drawings, and we've got to get out there and show them this is the way it has to be installed if we want this building to be to perform like it needs to. And here's a mock-up of window openings, penetrations, balconies, doors, whatever it may be. Here's how we're going to install in all those conditions, and once it's done, this is our reference point for the job.
You said windows, doors, penetrations, balconies. How do you get all that covered? Do you have to do, does one mock-up cover all, or sometimes you have to do more than one mock-up? Yeah,
I've seen some, and we've been on some projects where, and it could be a real process to try to put together a mock-up plan that incorporates all the details on a project. So we've had some that were very elaborate mock-ups with a balcony and various wall claddings and window and door types. Or, as you said, you may have to do several different mock-ups of different wall conditions and balcony to wall conditions. And they can be very elaborate, or there can be a series of more simple details, mock-up details. And some of that may depend upon whether it's going to be also an aesthetic mock-up that really shows people how the building's going to look, which is not our big concern, or if it's just going to be a functional type mock-up, then it doesn't really matter how pretty it looks. And we've done balcony mock-ups in the back of a pickup truck to get the details right.
Do they ever do these mock-ups actually do it in the building?
Yeah, and that's a good point. Yes, a lot of times, depending upon the schedule, site conditions, dollars, it may be that we just take maybe a corner of a building or a specific unit and accelerate it and get all the materials there and build an in-place mock-up that then doesn't have to be torn down. All the money's going toward the end construction then.
So when you say in-place mock-up, does that mean, well, let me ask you this first. When should that be done?
Well, early. The earlier the better. We'd like to see a standalone mock-up built, and I've been on many jobs where the standalone mock-up is built and we're out there working on the details and they're just starting to come out of ground with the walls. But if it's going to be an in-place mock-up, it's got to be the first of each of whatever it is, window opening, door opening, balcony. It's got to be the first one on the building. And like I said, we'd like to get the trades there a little before they're ready to just run with their product installation, so we can accelerate all those together in this one area of the building and get everything worked out up front.
So we do that, and then how do we know if it's going to actually perform or not?
Well, what we want to do is test it. We want to do water infiltration testing, which is a big part of what we do. We'd like to test those mock-ups, whether standalone or in place, with with an ASTM test that simulates a wind-driven rain, so we think we've got it right, everything looks right, we've got it all installed, let's test it now, make sure nobody overlooked anything, everything's performing like it should. We like to do flood testing on the balcony waterproofing in these types of buildings. Get water out there, test it, and make sure that our plan is solid and we've got a good path to move forward with the construction.
When you do these tests, do they usually pass?
No.
You can say it. Okay.
Yeah. Sometimes they do, but a lot of times a lot of times there could be installation problems. You may get everything installed properly, but something didn't get something with the window itself maybe was left out, or a problem with it, or some other issue that nobody even foresaw in all these installation details. So typically you're going to get some leaks in those early tests, and you're going to kind of work through that process to get things resolved.
So when you say work through that process to get things resolved, I'm assuming you do repairs and then you keep testing until you get it
Yes.
fixed.
Yeah.
And what happens after that to make sure, so you've got one window that isn't going to leak. How do you make sure the rest of the job is going to perform at that point?
Well, what we like to do is then conduct regular inspections throughout the installation process. So we're coming back on a regular basis because we all know things can get off track. Different people can be on the job. Someone can get confused as to what the details were in that mock-up, whatever it may be. We want to continue to inspect through that installation process and make sure that everybody's still performing the way they were when that mock-up was done. And then we like to do some confirmation water testing as the installation continues also, just to as another way of verifying that everything's still being done the way it should.
And when you do these confirmation tests, do you sometimes find that, do they pass, or do you sometimes find, that maybe there's something going on that would have otherwise been missed?
Yeah, I think, that certainly more of those pass because you've worked through some of those initial problems, but you can still, we still certainly see sometimes when there's failures in those types of tests where, like I say, maybe somebody's screwed something up from what our original plan was to the current point, or maybe we got a different condition that no one foresaw in the mock-up phase, some kind of a variation that's causing some issues that we find during a test.
When you do these tests, in the middle of the job or the end of the job, how do you know that particular area hasn't been given special treatment by the contractor, just to make sure that they pass the test?
Well, and that's certainly a concern, and we try to avoid that by selecting openings randomly. So, obviously, everybody knows a test is coming. Hopefully, everybody's installing every opening properly. But we like to have an area of the building where there's several openings, and we can pick some randomly to represent what's really going on, not, as you said, something that's been kind of beefed up to pass a test.
And then with the testing, what's the ultimate goal with testing as you're getting towards the end of the project?
Well, at the end, what we'd like to be doing is coming out there and everything we test is just passing the first time. And that's what that's what we always recommend is we want to get to a point where we can pick any opening and we can test it and it passes the first time we test it. And
generally, you'd feel pretty good about things at that point.
At that point, you do. Yeah. Sure. Nothing's an ironclad guarantee, but when you come out there and you've got several successive tests that pass on the first time, everybody's got a pretty good comfort level then at that point.
I know I've worked on projects before where, like big buildings, we've gone through this whole series and the testing went well and everything, and then they get hit with a extreme weather event after the fact. And I can remember one client in particular calling me up and saying, there was a big storm, tropical type storm, and I can remember the owner calling up and saying, I'm so happy I only had 4 leaks. Whereas if we hadn't done the testing, the whole building might be flooding.
Right, yeah, right. And if it's someone like that has been there in the beginning and seen that first test when maybe there were some problems, and they're kind of doing the math in their head and saying, well, if we hadn't done that, that could have been at 1,000 openings. And so 4 is a pretty good number in an extreme event.
So, Chris, thanks so much for being a guest on Everything Building Envelope. I know that this, these weatherproofing of exterior walls is a very interesting topic to a lot of our listeners. So I hope that we'll be able to get you back for some more episodes. I know there's a lot of things that we can talk about with your expertise and that we can dig deeper into.
Yep, sounds good. I'd be happy to come back anytime.
So with that, we're signing off. Thank you, everyone, for listening to Everything Building Envelope, and we'll talk to you next time.
Thanks for joining us today. Please subscribe to this podcast on iTunes or Stitcher. For more information on the Everything Building Envelope, previous episodes, show notes, bonus video content, and much more, check out our website, everythingbuildingenvelope.com.